So today we will start the third unit, that is a vacuum distillation unit. In this unit we will discuss about the operations of the vacuum distillation column. So first thing, what is vacuum distillation column? In this column, basically the definition as suggests the column that is operated under the vacuum. Sometimes vacuum pressure is known as the negative pressure from the atmospheric or the subatmospheric pressure. So it is lower than the atmospheric pressure, that is called the vacuum pressure. Due to the feed in vacuum distillation unit, feed is vaporized below its normal boiling point, therefore did not crack. So that is basically one of the very important thing in the vacuum distillation column. In other words, vacuum is maintained to avoid the cracking and corking in the feedstock. So basically this is the purpose of the maintaining a vacuum into the vacuum distillation unit. And as far as the feedstock is concerned, the residue, that is a long residue or atmospheric residue, both are the same, is the feedstock for the vacuum distillation unit. And what is the objective, why we need the vacuum distillation unit? So we know that about 50% of the residue about the crude oil is in the form of residue, long residue. So our objective is to remove the maximum possible amount of the distillate from the charge stock, that is from the feedstock, but you have to maintain the product specification of the vacuum distillation as well as the residue. So product means distillates and the bottom residue, both specification has to be maintained with the maximum possible amount of distillate. This is basic objective of the vacuum distillation unit. Distillate cuts are basically used to feed the material, feed the different units for the different conversion units to produce a highly value added products. So the products are the distillates from the vacuum distillation are very useful. They are going for the secondary conversion reactions. This is a simple diagram for the products from the vacuum distillation units. So one part is the distillate and second part is the residue. In the distillates, lube oil, gas oil, fuel oil, these three products are taken out. In the residue, either we go for the pitch operation or the asphalt operation. Now let us look closely about the each distillates. So the first one is the lube oil. So what we have to think about the lube oil? So basically the lube oil, the main criteria for selecting and for managing and producing the lube oil is the viscosity, the rejection to the residue of the heavy impurities, color, and up to the certain extent the boiling range. So these are the some principal criteria, but the boiling range is not as necessary up to the same degree as in the case of the atmospheric distillation. Means you can maintain the boiling range also for the production of lube oil, but that can be if there are 2 and 3 degree changes as your objective, with your objective. For example, you want to produce the 650 degree Fahrenheit products and now the products are 670, so there are 10 degree difference. So you can tolerate that 10 degree difference in the vacuum lube oil productions, but in the atmospheric you cannot tolerate. You have to make some arrangement for that 10 degree, that is stripping, side stripping. But in this case we don't need these things, so we can say that the separation is not tough as compared to the atmospheric distillation column. The second thing, it must be free from the CCR, condensation carbon residue, that is a CCR. And the second thing, the metal content. The metal content is basically an indication of poor fractionation. It should also be not present in the lube oil, but there are no stringent requirements. Means a very small concentration of metals can be there in the lube oil. So that is the things that you should know about the lube oil. And third thing is, these oils are usually refined by the solvent extraction process and some other type of treating processes like hydroprocessing for the before the finishing products. So overall we can say there are two parameters that we have to consider. One is the conventional carbon residue and the second is the metal content. These two have to be maintained. So similarly for the second products from the vacuum, that is a vacuum gas oil, we have to consider these two products with the help of these CCR and metal content. So in this one, the gas oil is not a product, basically it is an intermediate product. You have to heat that gas oil for different units. For example, sometimes we can use the gas oil for the feedstock for catalytic cracking. So at that time you have to take care that there are good separations required between the distillates and residue, and these oils, means this gas oil, should have the minimum amount of CCR value without sacrificing the gas oil recovery. And this is necessary. Why we need a very low value of CCR? To prevent the excessive laydown of coke on the cracking catalyst, because if the CCR are not controlled, then it will basically deposit the coke on the cracking catalyst. So you need to maintain the minimum amount of CCR. The second, metal content, second parameter, it should be limited. For example, vanadium and nickel, these should be limited because they are very much poisonous with the catalyst. So in short we can say that CCR should be minimum, metal content should be minimum. But sometimes if you are using gas oil as a feedstock for hydrotreating or hydrocracking process, so at that time CCR is okay, you need to minimize the CCR, but the metal free is not necessary, because these metals, these vanadium and nickel metals are often used as a hydrogenation catalyst. So there is no need to metal free for the gas oil when you are using for the hydrotreaters and hydrocrackers. But it should be free from the carbons and asphaltic materials. So if they are not coking up, the catalyst will occur more rapidly and more frequent regenerations will be required. So ultimately here you can control the you have to vary about the coke concentrations, but don't worry about the metal. Third distillate is a fuel oil. So in that one also, in fuel oil you have to first take care about CCR and metal. So in the distillate fuel oil, normally which are used without the further processing, means these are the taken as this fuel oil is taken as a finished products, as normally controlled or specified by the API gravity, viscosity, metal content, flash and fire point. These are some specifications. If it is matched, then you can take that fuel oil as a product directly to sell in the market. Atmospheric boiling range, either TVP or ASTM, can be used to define the separations. And metal content, particularly vanadium, is the source of ash and is also harmful to most furnace refractory materials. Normally these fuel oil are used for burning in the submarines and some other burners, and basically steam crackers and some other places. So what happened, you have to concern about the metal content, vanadium especially, because if the concentration is high, then it produces the ash, and sometimes it's also give the negative effects on the refractory of the furnaces, because fuel oil is used in the furnaces also. So this is all about the three products from the vacuum distillate. Come to the residue. So there are residue, two types of residue are there. One is considered as the pitch operations. Pitch type of residue are produced. What happening in this type of operations? In this type of operations, the distillate production has to be maximized. You want to produce maximum amount of distillate. What happen if you are going to produce maximum amount of distillates? So then the residue will be very much thick. So the amount of gas oil allowed to remain in the bottom steam must be minimized, and thus the material that is residue is normally 0 to 5 degrees API. It's a very thick basically material, and it is blended into the residual fuels. This is called the pitch operations. And come to in the pitch operations, the quality of residue of a little importance than the minimize its content of recoverable oils. We are more concerned about maximization of the amount that is present in the residue in the pitch operations. But in the asphalt operations, what is happening here, you have to maintain certain plasticity. In the asphalt operations, some gas oil must be left in the residue in order to provide the proper degree of plasticity. Means there should be some plasticity, some flow, a small flow nature. So for that you have to maintain the asphalts in the range of 5 to 8 degree API, slightly higher API as compared to the pitch operations. Not all crude can be used to make the asphalt, since this is a question of whether or not a particular residuum has the proper composition of matter to render it suitable for asphalt applications. So normally we have, majority of the cases we have to go for the pitch operations, and if the materials are suited, if the residue are suited, then we can go for the asphalt operations. So this is, in the asphalt operations the oil quality must remain high, but the residue must meet certain stringent specifications. Here the residue also have the specifications along with the distillates. So that's why asphalt operation is not easy as compared to the pitch operations. This is some basic image of the vacuum distillation column, where the residue feed is going with the help of furnace. You have to charge, you have to heat the residue up to the higher temperature, and then it has sent in the column. At the top there are continuous procedure, complete procedure for maintaining the vacuum, and we have a different sections. Like these sections are there, these sections where the vapor liquid equilibriums are taking place, mass transfer zones are there, and we can have LVGU, HVGU, light vacuum gas oil, heavy vacuum gas oil, slope oil, overflash, vacuum residue. These are the products that we can obtain. So if you look about some images, these are some few images of the industrial images of the vacuum distillation column. Thank you very much.